So now we're going to take a few quadratic functions and rewrite them by completing the square. And again, keep in mind this is only possible for quadratic or degree 2 functions. And we don't always want to do it, but when it's in this form, a quadratic, again, that's a degree 2 is the highest power. It's easy to type into our calculator. When we start solving, this is a pretty good form for us to have it in to solve. But if I want to know what the parabola looks like, this is not the best form for it. I don't see shifts and things like that. So completing the square just gives you another way to write this same function, but in a more graph-friendly form. Okay. So remember, there's just a few steps. So the first thing we do is we have to factor out that leading coefficient, which in our case is a 3, just from the first two terms. Okay. So the 3, we take it out here. We have x squared plus x. Okay. We don't worry about the constant term, so we leave that outside. Okay. Now we're going to complete the square. That's why we left a blank here. Okay. So we take our middle coefficient, which is a 1. We cut it in half, and then we square that. So 1/4. So that number, 1/4, is what will complete the square. So I want to put a plus 1/4 here. Okay, now keep in mind, I've just changed the problem. We're not allowed to change the function. So I wrote plus 1/4, but remember it's sitting inside a parentheses getting multiplied by 3. So I really added 3/4 to that function, which means I better subtract 3/4 to keep everything the same. Okay. But now, because we have completed the square, I now know that this parentheses is a perfect square trinomial. Okay. And the x squared becomes x, and the 1/4, remember, came from the 1/2. Okay. And you can double check that if you squared this out, you would have your x squared, you have your 4th, and then remember you have your outer and inner terms. Each would be 1/2 x, adding up to be 1x. Okay. Then I just have to collect my like terms out here. So I'm going to get my common denominator. So that's 24/4. And so I would have p of x equal to 3 times the quantity x plus 1/2 squared minus 27/4. Okay, and again, the advantage is I can now see my shifts that happen to my squaring function. So it went left 1/2, so my vertex moves back to negative 1/2 and down to 27/4. Okay, it's being multiplied by 3, which puts a stretch on there, but it's positive, so it's not flipping. It would still open up. Okay. All right, so let's do this for a few more. So we have p of x equal to negative x squared plus 3x plus 10. Again, our first step is to factor out the leading coefficient, which in our case here is a negative 1, from the first two terms only. Remember, you're going to complete the square with the correct constant, so we don't have to worry about that plus 10. Leave it out there. And at this point, we have not changed the function at all. Just factor out a negative 1. Okay. But now we need to complete the square. Okay, so we take our negative 3. That's the coefficient of x. Divide it by 2. And then square it. So we get 9/4. That's the number we need there. Okay, so and again, it's always going to be positive because we square it. So we're going to have to add 9/4. Okay, now you've changed the problem. Okay, but again, you wrote 9/4. It was sitting inside a parentheses being multiplied by negative 1. So you really put a minus 9/4 on this side. So you put a plus 9/4. That'll balance it out. Okay. So now you've completed the square. So this, in fact, is a perfect square trinomial. X squared would always come from the x. And remember, the 9/4 came from the minus 3/2. Okay. And then again, we need to collect these, so I get my common denominator again. And p of x equals negative 1, or just negative if you want. X minus 3/2 squared plus 49/4. Okay. It's the same function. If you type the original in your calculator, you type this in your calculator, you get exactly the same parabola. There's a reflection, so it'll open down, and then your vertex will be right 3/2, so 3/2, comma 49/4. Let's just try this for two more here. Now again, keep in mind for number 3, you have negative 4x squared plus 4x. There is no constant term, which is fine. It's still a quadratic because there's a degree 2. To complete the square, we factor out that leading coefficient no matter what it is. So in this case, it's negative 4. That leaves me with a positive x squared minus x. Keep in mind there's no constant term, so that's all I have so far. Okay. Now I want to complete the square, so I take my coefficient, which is negative 1, the coefficient of x, cut it in half, and then square it. So that 1/4 is what needs to be put here to complete the square. I wrote 1/4. It's sitting inside this parentheses. So negative 4 times 1/4 is really a minus 1. A plus 1 balances that out. So again, we've completed the square, which means we made our perfect square trinomial. Okay. The x squared came from the x, and the 1/4, remember, came from the minus 1/2. And here we just have a plus 1. So again, if the question was where's the vertex, I now see I went right 1/2, up 1. And then finally for number 4, again, we start by factoring out the leading coefficient, which is a 4. Now it doesn't come out of 3 so well. Remember, factoring out is dividing out. So you just divide it by 4. So you'd have a 3/4 x. Okay, just double check, right? 4 times x squared is 4x squared. And then the 4 times 3/4 x becomes the 3x. Okay, the minus 1 constant, we just leave up. All right, so we take our coefficient, which is 3/4, cut it in half. And remember, that just doubles the denominator, so that'd be 3/8. And then I square that, and I get 9/64. That's what will complete the square. So I put a 9/64 here. Okay, I wrote 9/64. It's sitting inside a parentheses, being multiplied by 4. So the 4 and 64 cancel, and I get 9/16. So I put a minus 9/16 to balance that out. So P of x equal to 4. I've completed the square. X becomes x squared. Remember, 9/64 came from the 3/8. And again, I'll get a common denominator out here. 1 is 16/16. And so I wind up with 4 times the quantity x plus 3/8 squared minus 25/16.